The Doppler effect is a phenomenon that occurs when a receiver of waves is in a different frame of reference than the emitter. The different energy states of our reference frames lead to differences in measured energy levels in the wave. The universe is rapidly expanding, and thus all faraway points in space are moving further and further from each other's frames of reference. So, when light arrives, it appears far weaker than one would expect. This is called redshift. As touched upon in my previous video, points in space expand away from each other based off Hubble's constant. This is a measured factor predicting that points in space expand from one another at around 70 kilometers a second every megaparsec between them. On a universal scale, this speed is inconsequential, but over extreme vast distances, that cumulative 70 kilometers per second adds up, and eventually points in space begin expanding away from each other at relativistic speeds. Waves are energy, and energy must be conserved. So when we see light or hear sound waves, it can seem strange that they possess more or less energy than they originally did. But the first law of thermodynamics is safe, as this change in energy can be found by the difference in energy states of our reference frames. A frame of reference is simply how you describe something's motion based off something you define as motionless. A good rule of thumb is using whatever you're gravitationally bound to. So your and my motion would be defined by the Earth, the Earth's motion would be defined by the Sun, and the Sun's motion would be defined by the center of the galaxy. However, you can choose and change your frame of reference at will. The biggest difference between an adept and struggling physics student is how you choose your frame of reference. I'm gonna imagine you've probably already seen a video or demonstration of the Doppler effect using sound waves, and there's plenty of sources that can visualize that as well as I could. What we're going to explore soon, however, is the relativistic Doppler effect. The Doppler effect occurs because waves always move away as fast as their medium allows them. Unlike particles, they don't inherit the velocity of their emitter. Waves leave an emitter at the same speed regardless of the emitter's velocity. This results in a very visible clumping and stretching of waves along the direction of motion. But anyone in the same frame of reference wouldn't observe these changes as their motion counteracts these compressions and stretches. Relativity shows that light always has the same speed or velocity in whichever frame of reference you choose. Therefore, the only difference between light in one reference frame and another is the energy it possesses. And since a light's energy is dictated by its wavelength, then the only difference between light in one reference frame or another is its wavelength. Redshift is always described as space stretching light out, and we'll find out soon this is an acceptable explanation, but it's also a little deceiving to the true nature of light and our universe. Light or photons are simply an excitation of the electromagnetic field. They don't have any dimensions. You can't stretch a point. That notion doesn't make sense. Because light doesn't have rest mass, it must move. And since it moves at c, or the speed of light, it mathematically doesn't have a reference frame. If, however, we then describe light using an arbitrary frame of reference, we can plot its movement along with its oscillation, and now we can visualize and describe it by its wavelength. Wavelength is a description of light, not something it physically has. By focusing on its wavelength, it then